Hi everybody, welcome to this miRack tutorial. Today I would like to show you how to use oscilloscope so that you can visualize in a visual way the patches that you are creating. So let's click on create patch to create a patch inside the miRack. Let's click on the plus sign and let's stay on the basics section of the packs category, and let's click on oscilloscope EQ102 envelope oscilloscope from Submarine. Let's click add patch. Okay, and then also let's add for the purpose of illustrating how to use the oscilloscope, let's add a VCO from Vogue Audio. So let's add the patch. Okay, so next what we are going to do is to connect the output of the VCO to an input of the oscilloscope, and we do that in this way. I'm not going to connect for the purposes of this tutorial anything to the audio out, otherwise you would just hear the oscilloscope, because the purpose of this tutorial is really to explain how to use the oscilloscope itself. So let me zoom in a little bit more so you can properly see. So as I just mentioned, we connected the output of this sound wave form from the VCO directly into the input of the oscilloscope. And we connected directly to the channel A input. There are two channels, channel A and also channel B. As you can see here, for each one of the channel there is a selection for CV or notes, and if you select notes you will have you will see that the oscilloscope will rectify the sine waves and also will show it in a solid state. But for the purpose of this tutorial, let's keep it on CV. Here you have a dial which is called offset. As you can see, you can move it up and down, and it gives you also measurement involved, as you can see here, minus 2.850, and here you have an indices, and if you look at, there is a horizontal indices. If you can move that up, you can see that as I move it towards the center of the wave, that tends to go to 0. Okay, in this case it is 60 millivolt, okay, roughly to 0. So as I said, going back to the channel A, you can offset it up and down, and therefore you see a different measurement of volt based on that indices that I just mentioned. You have a scale dial which you can scale up and down that wave. Okay, you can apply the same to channel B, and you can have another input there. So let's take these another waveform from the VCO, and let's connect it to channel B. And as you can see in red, now you have another waveform, and if you're not happy, you can choose another one, for example square. Okay, sawtooth, okay, and so on. Moving on, you have a time dial. Okay, and changing that is like scaling the time on your horizontal axis, and that is important, because if you have a high frequency, for example, if I go back to the VCO and you are looking at something with a higher frequency, then you can change the timing to visualize better, okay, that waveform, and you can go deeper, etc. Okay, so I'll give you an example like this, and let's adjust again the time. You can get very close to what that waveform looks like. All right, you have also a pre-trigger buffer which records up to 100 sample, which could come handy. The triggering inside the oscilloscope to visualize again, to refresh the display, can be driven by an external signal, like in this case, which you will connect it here. And you can adjust the level to which you will trigger, like this. And the trigger at the moment, by default, is driven by channel A on the rise edge, okay? And you can see that while it's still inside the sine wave and it is on the rise edge, if I change the VCO settings, you can see the changes there. But once I move that level outside the sine wave and it's not anymore on the rising edge, changes on the VCO will not affect the changes on the display of the oscilloscope. So that's important to keep that in mind. Okay, here you have a continuous update of the display on the oscilloscope only once. If you click on once, then you can click on run to have a different view. So in this case, if I update the frequency of the VCO and I click run, it will update the display once more time, or I can click back on continuous, so it will update as any changes occur. Then you have, as I mentioned or alluded at the beginning of the tutorial, three indices, a left, a right, and a horizontal, which can be very useful when it comes to measurement in volts. As I said earlier, there's an horizontal one, so you can see straight away, you can measure where you're up. It goes up to 5 volt and down to minus 5 volt, which you can see there. But you can also a left index. As you can see there, it drives the time. So in this case, it says 35.32 milliseconds. If you move it to the right hand side, it will say 0. Okay, so you can say, okay, I want to measure from there to each. You move it right to there, and it will tell you it's 8.571 milliseconds. And so that could come extremely useful when you're working on specific design of sound waves. Yeah, I hope you found this interesting and beneficial. So see you next time. Bye.